Welcome to day 3 of the event, and at this point, I suspect we've all heard a bit about IoT, but I want to take you on a little bit of a journey today. Oh, I'm going to switch here. Take you on a bit of a journey today, and I have to warn you in advance, there's a little bit of audience participation throughout this session. Now, if you take a look at all of the analyst statistics, and we've read them all, 50 billion devices connected by 2050, it's an impressive number, but what's really more impressive is what it ultimately translates to in terms of economic impact. According to McKinsey, it could be upwards of $11.1 trillion by 2025. Now, for those in the audience, that's an important number because ultimately 70% of that will benefit businesses. And in fact, by some estimates, organizations could stand to reduce OpEx spending by up to 15%. So there's a fundamental sea change in the way that we think, act, and operate, both as individuals and as professionals, as we start on this IoT journey. But I want to level set just exactly where we are relative to the progress we've made. We're still very, very early. Some of you, I think, will recognize the chart up here. It's the Gartner hype cycle for the Internet of Things. And if you walk through the show floor, you're going to hear people talk about data and analytics, and in fact, they're going to talk about machine learning and deep learning, AI, if you will. And if you look up here, what you'll see is that we're still 2 to 5 years out from machine learning, deep learning really starting to plateau. And in fact, what's really interesting up here, if you look at IoT platforms, you'll see that they're 5 to 10 years out from reaching their peak point of inflection. And that's probably true because when you look around, there's well over 400 IoT platforms available. And clearly, we as organizations, individuals, don't need that many different platforms. So there's going to be a fair amount of consolidation taking place. And even some of the things that we often reference as part of IoT, like autonomous driving, are still in their infancy. We're not going to see real autonomous driving for decades. And I always get the, Steve, haven't you read the papers? Well, sure. I understand that cars today at a level 2, L2, have some aspect of autonomous driving, but fully autonomous vehicles are certainly well over a decade from becoming reality, I think, in our society. Now, we're not strangers to disruption. We've seen disruption before. We've seen transitions before. Back in the 1860s, we saw the Industrial Revolution, the mechanization of machines and man coming together in the factory to forever change how we produce goods and services, right? And it has stood the test of time. 100 years later, when we flash forward, what we see is the computer revolution. In the 1960s, IBM introduced the first mainframe computer. Now, what was kind of interesting, at that point, a gigaflop, a measure of compute power, cost around $18.3 billion. Today, that same gigaflop is a little under a nickel. So we kind of see that computing power is growing substantially. Everything is getting connected and instrumented. But at the core of this is really something that we've all come to appreciate, and that's data itself. Data has become the new natural resource, so to speak. We are in abundance of data. And data, I would argue, once thought to be the solution, actually has become the problem in most of our businesses. How do we manage the onslaught and growth of the very amount of information that's being produced? More on that as we move forward in just a minute. Now, some of you will have seen variations, I think, of this chart showing kind of the confluence of factors, things coming together, but it really is the perfect storm. The reason we're sitting here isn't just because the Internet of Things has become interesting, it's because the ubiquity of the Internet itself lends itself to complete access. Mobility provides the medium for which we can interact, the device. Data has become free and flowing. And analytics has progressed. Now, analytics has been around for decades. Statistical modeling, data mining, techniques have been around since certainly the 70s. But finally, they've reached a point of inflection where we can use them in the day-to-day activities to get better insights and understanding of our business. And it's this confluence of factors, this convergence of things that really makes the session here today, the event itself, that much more interesting to all of us. So let's go ahead and then jump into this. Go ahead forward. Maybe. Nope, we're kind of locked up here. There we go. So when you look at where we are, it's a little bit scary. This is a chart from IDC. And what it shows is on the grand scheme of things, we're literally looking at a tsunami of data coming forward. Today, there's about 16 zettabytes of information in the world. 90% of the world's data has been created in the last 2 years, and the majority of that data is unstructured. And I would offer a perspective that we haven't really seen the effect of this growth of data in the business world, largely because our traditional legacy systems, deterministic systems, only are using structured information. They're using information neatly organized into rows and columns, quickly searchable, retrievable, but largely it's the treasure trove of unstructured data, newspapers, blogs, periodicals, maintenance reports, doctor's records, that are truly interesting. And in fact, over the next 10 years, a little bit less, the amount of information will grow tenfold. So picture where we are today and picture the tsunami of data coming into effect. What are we going to do with all the data? We can certainly choose to ignore and to avoid, but how do we actually harness and mine that amount of data? Now, I don't know about you, but I struggled a bit with this idea of a zettabyte and how that kind of related to my daily life. So I did a little bit of back of the envelope calculation, and it turns out there's about 2.5 quintillion bytes of data created every single day. So there you go. Okay, so if you actually transition that into something that we can relate to, that's about 170 newspapers delivered to every man, woman, and child on the planet every single day. So you get up, you walk outside, you grab your cup of coffee, you look at the pile of 170 papers, I give you a question, and I offer you a challenge that the answer is somewhere in the 170 papers. Day one, I'll give you a sporting chance that you will find the answer. But by day 10, that stack of papers has grown to 1,700, and the possibility that you'll find the needle in the haystack has diminished dramatically. This is, in fact, what we face in our businesses every single day. Now, to unlock that information, right, we have grown accustomed and turned to analytics. And there's all forms of analytics, and we kind of toss that term around ubiquitously, but the reality is there's descriptive analytics, which we appreciate, the reporting, scorecarding, and dashboarding of information. We use that every single day in our business from our various legacy and other operational systems. You move up the stack, we start to get a little bit more introspective. We find predictive analytics, being able to project future states, what is likely to happen, when will a piece of equipment fail, perhaps through a predictive protocol. We continue on the stack. We look to optimize, stochastic optimization, given the constraints of our business. What is the right course of action? Ultimately landing on the destination of AI, of what often we'll talk about machine learning systems that with our aid are able to progress and deal with probabilistic issues. You know, what is the confidence of a particular outcome or state? Into deep learning, systems that can progress independent of man, unaided and unsupervised learning of machines. But I have to tell you, I mean, with all of the hype around artificial intelligence, in fact, you can't literally pick up a paper or a magazine and not read something about AI. I don't know about you, but the minute I hear AI, I kind of turn to the Hollywood, to the movies. I think about Terminator, right, and Skynet, and that's kind of what AI conjures up. But for this morning, for business, I want to give you a very different perspective of how to think about AI. I want to think about augmented intelligence, not artificial. Now, turns out that augmented is something that we're actually really comfortable and familiar with. The human form is impressive unto itself. The average individual can bench press about 135 pounds. They can deadlift about 150 pounds. But man overcame this physical limitation. In 1896, man patented the first steam shovel. Right? This mechanical marvel was able to lift 16,000 pounds in a single scoop. So while our physical form had limitations, we basically augmented and it allowed us to progress to a greater state. The human eye is second only in complexity to the human brain. It may surprise you to hear that the human eye has about 2 million moving parts. You can see about 500 shades of gray and 2.7 million colors. On a clear day, we can see out about 3 miles. But again, man augmented that capabilities with the Hubble telescope. We can see out 15 billion light years. So we begin to see that we have altered our physical limitations and extended them through this augmentation process, much the way we have done this in a cognitive way as well, through our mental capacity. So here's the first part of today's interactive session. I'm going to run through a little exercise here. We'll see how well we do. The problem begins with 2 times 2 times 2 times 2 times 2. Everybody with me so far? We got 32. Pretty straightforward problem, but you begin to realize that with a modest amount of tweaking, right, our cognitive capabilities become overwhelmed. So let's do this again, right? Slightly more challenging. Stay with me. We're going to go 2 times 4 times 8 times 16 times 32. How many here came up with 32,768? You can quickly start to realize that without augmentation, we overwhelm both our physical and cognitive capabilities. And this is core to the work that's being done today within the IoT. I'll bring this all back together in just a second. The way we overcame that cognitive limitation, at least mathematically, is this 4-function marvel, right? I could add, subtract, divide, and multiply. And in fact, I still remember our first family calculator. It was in the late 70s. It was a Casio that my dad brought home, and we literally marveled at its ability to move out to 8 decimal points of precision. So again, man created, right, a situation to overcome, in this case, its cognitive limitations regarding mathematics. But it's not just, right, the computational characteristics that we're seeking to augment. Many of you are familiar with the devices up on this screen. We have been fascinated with a science called computational linguistics for almost 50 years, right? Began in London, I think I'll attribute it to. But the idea of natural language processing is becoming pervasive. We're seeing these devices certainly show up in the home. We can control the blinds or the lights or change the temperature. We can ask about the weather. We can order dinner through these various devices. But interestingly, this is still a substantial challenge to overcome. Let me give you an example as to why this is so hard. So I'm going to give you a little test. Here's the answer. This comes from out of the President Lincoln's blogs from the U.S. It says, Treasury Secretary Chase just submitted this to me for the 3rd time. Guess what, pal? This time I am accepting it. What is it? Someone said it. So resignation, right? Natural language isn't that hard, except we were actually giving this talk to a group of middle school students, and no sooner had we read the answer that a girl in the back raised her hand, fervently waving her hand, says, I know the answer. And we said, what's the answer? She says, a friend request. You begin to see that being able to put content into context is so critical, especially in the world of IoT. Simply understanding the data or having access is not sufficient to the interpretation of that information. Now, clearly, we are on a crusade to connect everything. We have connected our laptops and our phones. We're connecting our cars and our thermostats. It is becoming prolific. And yes, to Miko's point, we are connecting our toasters and our rice cookers. It is amazing everything that we're putting a chip and connectivity into. But I want to offer you a slightly different perspective. I want to offer you this perspective that what we've really largely experienced is the idea of simply connected. Many of us in the audience have a watch or a Fitbit or a device that's connected to our phone that tracks our steps. And certainly it's interesting to observe how many steps I take on a particular day. But in the event that I lose that synchronization, my life will not end. I will resync, I will go on, the day's activities won't be captured, but that's okay. Much the same way that we've gone and instrumented and connected a lot of what's happening in our home. I can sit on my couch today and control the thermostat. Certainly, it's a convenience that I appreciate. But at the end, if my Wi-Fi drops and I have to get up and manually change the temperature, right, it's not mission critical. And while it's again convenient to connect the other aspects of my home, it's nice to be able to look from my phone and see what's inside of my refrigerator, to start my washing machine, to check on the status of my charging car in the garage. None of those, should they fail, would really alter, right, my state of being. Life would go on. But there is a whole set of things happening in the world of IoT, or the industrial side of the Internet of Things, that I want to offer a different perspective on, and that's critically connected. These are the things that if they stop working, right, can potentially have a catastrophic series of effects. And in this capacity, it's really where Honeywell as an organization has focused. We've taken our deep domain knowledge, 100 years of business experience, the relationships of our customers, and we've begun to extract and appreciate the idiosyncrasies, the nuances, how to put content in context to solve real problems. Literally, hundreds of millions of homes, tens of millions of buildings, tens of thousands of planes, all are connected and operating today and providing new insights and opportunities. And if these things fail, we have a problem. These are mission-critical type applications, and it's the work that we are doing. Now, I want to give you a couple of quick examples of what that really looks like. Every day around the world, there's about 80,000 flights. And clearly, what we want to do is find a way to continue to improve the general outcome, create a win-win-win situation. Well, with IoT and connecting these aircraft, we're now able to analyze all of the information coming off of a plane and quickly provide feedback in terms of how to optimize fuel efficiency. The net effect is we've reduced fuel efficiency by as much as 5%. Now, that's good for the airline because it's their largest single cost of operations, right? So their bottom line improves. It's good for the environment because we put out a heck of a lot less pollutants into the air. But it's good as passengers because what happens by reducing fuel consumption is, it ironically turns out you get me to where I want to go that much faster, route optimization and such. So this is what the Internet of Things is starting to provide and facilitate is better outcomes that create a balanced win-win for all parties. Let's go ahead and take a look at something like a processing plant, a oil and gas refinery, if you will. These plants to set up can cost upwards of $750 million. Substantial investment. You can imagine the complexity of keeping these plants running. When these plants go down, people panic. Now, the typical liquid natural gas refinery will have 5 unplanned shutdowns during the year, unanticipated events that cause that plant to stop operating. The cost of that is upward of $25 million US. But what if everything was connected? What if every valve, pump, actuator, every processor within that plant was connected? And you started to be able to sense, to predict where problems are likely to occur and prescriptively do the preventive maintenance, right, just in time to stop that plant from coming down. Well, not only is that good for the plant operator and keeping the plant running financially, but we as individuals become dependent on the byproduct of what that plant produces. So minimizing disruption, good for the operator, good for the organization, good for us as individuals. We can start to see the connectedness and impact that these type of critically connected things have in our world. And finally, buildings. All right? Buildings are pretty prolific throughout our world. What's interesting is buildings consume about 40% of the available power in the world, so up to 72% of the available electricity, and they produce about 39% of our carbon emissions. So we care about buildings, and obviously buildings in some cases are like running small cities. But again, the ability to provide control, down to the micro level, to the motor, to the operator, to the chiller, to the pump, to the air conditioning system, allows us to start to become really efficient. In fact, we can reduce, in some cases, the energy footprint of these buildings on average by well over 20%. Again, good for the operator, good for the environment, right? Good for us as individuals in terms of adapting to our needs. So you kind of get a pattern between the airplane and the plant and the building, and it's really no different than in our home. This is all very real today. You can walk out on the floor, you're going to see organizations that have analytics and data capabilities, that have edge devices, that are instrumenting our world to change what we do. So I thought it would be interesting to leave you with really 10 predictions of where we're going. Number one is the sensorization of our world. Now, sensors aren't new. We've had sensors around for a while. But these multimodal super sensors, right, have literally come down to a price point that we're beginning to put them on everything. Why not measure temperature, humidity? Why not measure vibration, geolocation? Right? I can do this all now with a single sensor at a cost point that really affords me the ability to track almost a limitless set of possibilities. Two, video analytics. You can't walk around a building, an airport, even your home, and not be under constant surveillance. While interesting, the opportunity here is really to step up the video analytics side and begin to decipher what's going on in the picture. Right? Is that really my dog on the couch? Right? Or has someone else entered the room? Three, government weighs in on data access. You notice I didn't say data rights. We've already weighed in on data rights. We have regulations for privacy. We have provisions for certain types of data, health data, financial data. But now government's starting to look and weigh in on data access. Who owns it? Who should have access to that data? There's pending regulation now that's being discussed in the EU that would require organizations that have unique data sets to make them generally available to the market at large. So this will be a fundamental sea change in terms of how we think about data. Computing is going to go wild at the edge. More and more and more of the things that we have traditionally brought back to the cloud will stay at the edge. We'll collect data at the edge. We'll do real-time analysis and apply analytics and algorithms at the edge. We'll do it because, candidly, it's too expensive to bring it back to the cloud. In many cases, the latency factor of transmitting to the cloud and back doesn't afford us the outcome that we need. So I think you'll see a huge push at the edge. I think you're going to see, as Miko talked about, a very different challenge in the security arena. Effectively, IoT is weaponizing the internet. Right, go back to where I started, 50 billion devices, 50 billion points of entry, potentially, that could be compromised. And it doesn't take much, right, to recognize what the potential implications are. Miko talked about that earlier today. Businesses will think B2C to tackle B2B. I would actually argue there is no more B2C and B2B. It's all B2I. It's all business to individual. Your expectations, the way that you experience the world, doesn't change when you leave home and go to the office. If I can control my thermostats, my lights, my garage door, my blinds from my cell phone at home, why can't I have the same creature comforts when I'm in the office? And well beyond that. If my car is connected, why shouldn't my fleet of trucks all be connected? And so I think the behavior is such that we're going to have to start to think organizationally fundamentally different about how to tackle these problems. Machine learning will begin to outpace what has been the traditional statistical models. So data mining, data techniques, statistical processes like linear regression, logistic regression will truly give way to machine learning and then to deep learning. Natural language will displace keyboards. Right? Why would I ever want to type something in when I can just talk to it and have it recognize and respond? It won't be a single mega IoT vendor that wins. I suspect and predict it will be a cloud of clouds, platform of platforms, interconnectivity, complete transparency, As an organization, I don't need to know how the plumbing is working, right? It's easy enough for the vendors to figure out how to interoperate and integrate with one another through conventional protocols and through the use of things like APIs. And finally, I think we're going to see just a huge shift among businesses in terms of productivity gains. In fact, I would argue the single largest jump in productivity that we've experienced in over a century will come from IoT adoption. So leaving the session today, the way that I would encourage you to think about IoT is to fundamentally answer a couple of key questions. This comes out of a Bain study. But my interpretation is slightly different is, walking out is what problem are you trying to solve? Because there's a little bit of the IoT hammer-nail problem going on, right? It doesn't solve everything. Why is it a problem worth solving? Why is it a problem worth solving now? Turns out that IoT data analytics can solve almost everything, but not everything is worth solving simultaneously. There's a priority to it. Ultimately, why hasn't the problem been solved? Turns out that that's kind of the linchpin, because often the reason the problem hasn't been solved is something as simple as the data just isn't available. Well, no matter how good the connectivity and technology is, if you can't get access to data or data rights, right, then you're not going to ultimately solve the problem in your business. So I thank you for the opportunity today to present a little bit of thoughts. Hopefully this helps you on thinking about how to explain the Internet of Things to friends and family at home. Think about how to apply the Internet of Things in your businesses, and changes your perspective just a little bit on the world that's becoming critically connected. Thank you.